So, in this video, we're going to introduce you to the model building in Pumas. So, we create a model in Pumas using the add model, and we sandwich our statements between a begin and end block, as you can see in line 3 up to line 24. Here inside, we define all of our model blocks. For the first block that we define, all the param block, it's this add param, and it has its own method, begin and end. And as my comment says, here is where we define the parameters of the model. So here is where we define all of our theta's, all of our critical clearance or volume of concertation parameters. And this is also where we define our sigmas and also where we define our omegas. Would be either a capital omega for a covariance matrix or a lowercase omega or a simple random effect. And the next block is the add random. This is where we define our random effects. So this is where we put all of our etas. And we have next the 3 block. This is for pre-computations and any other statistical transformations. So here is where you do any nonlinear transformation like logistic of something, and then you say that this is a my transformation because this, and you can use your my transformation in the dynamics block or in the other blocks. And also here is where you define your PK parameters. So your PK parameters could be something like clearance equals my KVL times the exponential of eta clearance. Or that could be also a eta vector, so eta 1, for example. And finally, we have the dynamics block. Here is where we define our compartments and the dynamics, so our ODE system. So we're pursued by specifying a list of ordinary differential equations that governs our dynamical system, so our PKPD model. And we are free here to specify any parameters or any compartments. So I can call central prime, that is the derivative of the central compartment, is equal of minus CL divided by VC times the central compartment. I can also name this whatever I want. I can say this as compartment 1, and this is compartment 1. I can do other things. I can do compartment 2, derivative or peripheral derivative equals something else. And this is where we define each line 1 OD. The dynamics clock has also its own begin and end statement. And now finally, we have our derived block. So here's where we calculate concentration and any other observed quantity, and we add residual variability. So we can say something like concentration plasma equals that's vectorized, so equals central divided by the scene, and then we do something like dependent variable is distributed as log normal with a mean of log something or CP here, and standard deviation sigma. Or we can use a normal here if you want to. We can also use any distribution here whatsoever. I'm gonna go dive into the confinements in just a brief, but this is a brief overview of the model blocks.